This is a video lesson for section 9.6, factoring in the x squared plus bx plus c format. So this is a special type of factoring that's similar yet different from the factoring we did in section 9.5. In 9.5 we primarily dealt with factoring binomials, and 9.6 is going to primarily deal with factoring trinomials. So for example, if I told you to factor this particular problem, so x squared plus 5x equals to a 6. So how would you go about factoring this particular problem? Well, first of all, think about what this looks like. It's a trinomial, but it's a trinomial that looks like very much like an answer to a binomial multiplication problem. So essentially, if you had a pair of binomials and you multiply them against each other using the FOIL method, you would essentially get this particular answer. So let me show you an example of that. So here I have a pair of binomials being multiplied against each other. I'm going to use the FOIL method to go ahead and crunch my numbers. So x times x is x squared. X times 2 is 2x. 3 times x is 3x. And then 3 times 2 is 6. Alright, I'm going to do my simplification here. And I'm going to get x squared plus 5x plus 6. The same here. So essentially, this can very well be an answer to a binomial multiplication problem. Now, why am I showing you this when we're talking about factoring? That's going to make sense in just a second. So, what if I asked you to factor this particular problem? Well, since I told you that this format looks like an answer to a binomial multiplication problem, more than likely, you started off this problem with some kind of a parenthesis times parenthesis multiplication situation where you had a binomial here and a binomial here, and when you multiply those two binomials you got that particular trinomial. So most of these factoring problems you start out with a pair of parentheses, and then you look at the first term of your trinomial. So you look at the x squared, and then you think to yourself, what two terms when multiplied against each other will give you x squared? Well, the most likely conclusion that you can reach, although there's more than one possibility here, but most likely it was x times x that gave you the x squared. Terrific. So right over here, I'm going to write x and x. In the first position of the FOIL method, it makes sense. If x times x gives you x squared, that should be your answer. Now we're going to look at the other two numbers. We have 3 and 2. 3 and 2. So for the second half of the factoring problem, you're going to come up with two numbers that can add up to a 3, and they multiply to a product of 2. So two numbers that will add up to a 3, yet when you multiply them, the product is a 2. So what are these two numbers? Well, there is really only one possibility here, and that possibility is 1 and 2. 1 plus 2 gives us 3. 1 times 2 gives us 2. So that's essentially how you factor a problem out. Put your parentheses up, look at the first term, figure out exactly what two numbers have to make up that term, put them in the first position, then look at the next two numbers and figure out what numbers can add up to this yet multiply to get this. In this case it was 1 and 2, positive 1 and 2. So plus 1 plus 2. The order doesn't really matter. That's it, and that's the answer. That was pretty simple. And you can check this if you wanted to. If you FOIL this, you should get that back. So let's do another example. Let's do this particular problem, something a bit tougher. X squared plus 11x plus 18. And let's go ahead and factor this out. So just like before, you're going to start with a set of parentheses because more than likely this was derived from a binomial multiplication problem. Then you take a look at your first term. Same as before, it's an x squared. So more than likely it was made by multiplying a pair of x's. So you write an x here and an x here in the first position, because when you FOIL, first and first, x times x, x squared. Then you look at your two other numbers, the 11 and the 18. So I'm going to just write them up here, 11 and 18. And then you're going to ask yourself this. What two numbers add up to 11, yet they multiply to 18? Now this becomes a little bit tougher. I'm going to give you a hint. Look at the second number first and think of the multiplicatives that can make up 18 first. So 18 can be 6 times 3. Can you get 11 out of 6 and 3? No, no way. 6 plus 3 is 9 at best. 18 can also be 9 times 2. Alright. Can you get 11 out of 9 and 2? Sure. 9 plus 2 is 11. Perfect. So 9 plus 2 is 11. 9 times 2 is 18. Those are our two numbers. They're both positive. So we write plus 9 plus 2. Again, the order doesn't really make a difference. And that's our solution here. So what if I gave you a problem like this? Similar to what we have before. Actually, we don't need the equal sign. Similar to what we have before, except I threw in a negative in there. It's y squared plus 2y minus 15. It changed something, but not much. You start the problem in the same way you started before, with that pair of parentheses. Because again, more than likely, this is a product of a binomial multiplication problem. So look at your first term. We have y squared. What times what will likely give you a y squared? More than likely it was y times y. And I say more than likely because you can do y times y squared as well, but that's unlikely. So we're not going to consider that yet. Eventually we'll have to, but not right now. So I'm going to write y and y here to satisfy the FOIL first. First times first, y times y gives you y squared. Then I'm going to write my two numbers here. 2 and negative 15. And then I'm going to look at the two numbers and see what other numbers can add up to a 2 yet multiply to produce a negative 15. This becomes a little bit tougher. Hint, if your second number is a negative, more than likely you're going to have a combination of a positive and a negative number. So that being said, look at the second number, the negative 15, and look at all the multiplicatives. What times what can give you a 15? Well, 1 times 15, there's no way you're getting a 2 out of 1 on a 15. What about 3 times 5? A 3 and a 5. You can get a 2 out of that. It's a positive 2. So what about a positive 5 and a negative 3? Okay, let's try that. 5 minus 3. That's a 2. 5 times negative 3. That's a negative 15. Perfect. That works out. So our two numbers are a positive 5 and a negative 3. So slightly different, but not much different, not enough different that we have to really do anything new. So you still follow the same format, except the negative makes your thought process a little different because now one of the numbers has to be negative. Both of them can't be positive. Good. Let's do another example. So what if I give you a problem like this? Now this seems like a problem that we haven't really seen before. I mean, x squared minus 3x equals to 18? That looks strange. It's not that normal trinomial that we like to see in a factoring problem. But we can turn it into one by simply subtracting 18 from both sides. So I can very easily convert this into a trinomial by taking 18 off here and taking 18 off here. And then that turns into x squared minus 3x minus 18. And on the other side, there's just a 0. That's also new. We'll talk about that in just a little bit. So now that looks like a trinomial that we have dealt with. We've factored this before, so that shouldn't be too hard. And we'll deal with the 0 in just a little bit. Just like before, make your two parentheses still equal to 0. look at the first term, the x squared. What times what can give you an x squared? More than likely it's an x and another x. So x times x. Then look at your two other numbers. We have, I'm going to write them over here. We have -3 and a -18. Double negative. Well, that's interesting. What times what gives you -18, and what plus what will give you a -3? Very, very curious. All right, let's take a look at the second number and see what two multiplicatives, when multiplied together, will yield an 18. I can do 2 times 9. Can I possibly get a 3 out of a 2 and a 9? No, no way. But I can also do 3 times 6. Can I get a 3 out of a 3 and a 6? Sure. If the 6 is negative and the 3 is positive, then I can potentially get a -3 out of it. So if I write it like this, -6, -6 plus 3, that's going to yield a -3. Yay, good. And then over here, -6 times a +3 is going to yield us a -18. Perfect. That's probably going to work for us. -6 and a +3. All right, so now we have everything filled in. Except there's this little caveat where x minus 6 times x plus 3 equals to 0. We haven't had that before. So far we had expressions but no equations. This is an equation, which means it's got an equal sign, so we have to solve it to completion. But that's okay, because we've dealt with these problems in the previous section, 9.5. By using the zero product property, we know that either the first binomial, the x minus 6, or the second binomial, the x plus 3, has to be a 0. So we write it as such. So either the x minus 6 is a 0, or the x plus 3 is a 0. One or the other has to be a 0. So then, in this case, I'm going to add 6 to both sides. In this case, I'm going to subtract 3 from both sides. And I get x is either a +6 and or x is a -3. And this works because let's say I plug in randomly one of these two. I plug in the 6 into this equation here. So 6 squared is 36 minus 3 times 6 is 18. 36 minus 18 is 18. That works. If I plug this in, -3 squared, so -3 times -3 is 9, minus 3 times -3, that's a -9, which gives me a double negative. So I get 9 minus minus a 9, which is the same thing as 9 plus 9, and that's 18, and 18 equals to an 18. So both of these answers check out. So this was a video lesson for section 9.6. If you have any other questions, watch my homework video and or come see me during lunch, before school, after school, or ask questions during class. Thank you.